Hello and welcome to this instructional video on the Instant Energy Calculator for direct current, which is among a suite of 10 tools that are designed to allow a competent electrical engineer to determine the severity of an arc flash incident. My name is Mike Frayne and I'm the creator of the European Arc Guide and the author of the book The European Arc Flash Guide. To access the DC Instant Energy Calculator, select the Calculators tab and then DC Arc Flash. If you select Expand or Collapse, you'll be able to provide preset configurations, and that gives you access to comprehensive guidance on how to use the calculator. The calculator allows for you to determine the instant energy at a working distance in calories per square centimetre for enclosed and open arc configurations, and is based upon several theoretical papers. If we take a simple DC circuit shown here, which is subject to an arc fault, the current that flows in the arc is simply found by application of Ohm's law, which is voltage divided by resistance. So, the source voltage is divided by the sum of the series impedances made up of the source resistance, Rs, system or conductor resistance, Rc, and the arc resistance, Rarc. The calculations find values for the two unknowns, the resistance in the arc, Rarc, and the arcing current, IDC arc, which involves a process of iteration. This is all explained in the instructions. So, to complete the calculator form, an enclosure type will be required. The range is LV and HV switchgear, panel board or open air. We'll choose panel board. Next, enter the DC open circuit volts into the system volts field. In our case, this will be a value of 256. The next two fields deal with electrical network resistance. Enter the total conductor resistance from the source to the equipment in ohms firstly. We'll use a value of 0.00194. Then enter the internal resistance of the system or source into the system internal resistance field. In this case, our figure for internal resistance is 0.0115. Next, we have the conductor gap distance, which may be the distance between bus bars, equipment terminals, or cable conductors, and in this case we'll choose 25 millimeters. The working distance field represents the distance between the potential arc source, not just the front of the panel, and the face and chest of the worker. We'll choose 450 millimeters, which is a reasonable assumption for testing and calibration interactions, not forgetting that the hands will be much closer in those circumstances. At this stage, if we press the submit button, we are given a calculated arcing current of 11.43 kA. We can then use this figure to obtain the disconnection time from the time current characteristic for the upstream protective device. And so, having checked our TCC for this example, we'll enter a time of 0.4 seconds, which we have determined to clear the fault of 11.43 kA. As you can see, that pressing the submit button once again, this returns an instant energy of 6.69 calories per square centimetre, or you may wish to round this figure up. Finally, the result can be stored by pressing the Store Instant Energy button, and the result can be exported, printed or used in a dynamic risk assessment that is provided with this guide. As a brief glimpse of the form, we click on Calculators and there's an option that can be seen for risk assessment. This opens the form which, as you can see, is sectionalised for predict, prevent, process and protect. By selecting the Enable DC Arc Flash checkbox, this will automatically fill in the first part of the Predict section. This dynamic risk assessment checklist form will allow the user to systematically go through the 4P steps and consider the actions one by one. You can either complete the form online or download a Word document which can be custom edited for your needs. I really hope that you enjoy using the calculator in the field, either on your phone or tablet or your PC, and that you find this and the guide to be a valuable resource to discover and manage dangerous levels of electrical instant energy in the workplace.